Hello, and welcome to the Spilling the Tea podcast. I'll be one of your co hosts for today, Lisa Loud from Secret Network. And this podcast is called Spilling the Tea. We're unveiling confidential computing insights from industry leaders. It's not your average podcast. This is the Spilling the Tea podcast. And we have a really special guest prepared for today. So without further ado, I will introduce my co host. For today's podcast, we have Megan Nilsson, or Crypto Megan. Megan, take it away.
Hi, Lisa. It's really great to be here. I absolutely love these podcasts breaking down the wonderful, exciting, and sometimes a little bit scary world of AI. And it's great that we get such amazing guests like Anthony that we have on today to break that down for us, let us know what's happening behind the scenes. We got some incredible topics lined up for today, but our guest for today is Anthony, the head of research and innovation at iExec. So, Anthony, welcome to the show.
Hi Megan, hi Lisa. I'm so happy to be here, and I'm also happy to chat about, DCCTs. So this podcast is just perfect for me. I'm excited.
Yeah. Yeah, well, lovely to have you here. And before we get started, can you tell us just a little bit more about what iExec does?
hmm So iExec is a Web 3 project, and we provide tools and a platform for builders. Uh, and for builders who believe that their users should be the sole owners of their data. So with our tools and our platform, you can come and build applications where users keep control of the data, the ownership, the privacy, the monetization. You could put rules on pretty much anything. And our system runs in T's. And so by design, the rules are inviolable. And yeah, that's pretty much it. You can build pretty much unique things in Web3 where control and monetization is given by default.
Amazing. Anthony, so just tell us a little bit about how you got to this space. I mean, for sure, AI is a big topic today, and I'm assuming that you're pretty passionate about it. What's your journey? What led you to this point in your career?
So I'm originally a researcher in distributed systems, cloud computing. I have contribution to the implementation more of very advanced distributed computing platforms, and I naturally went to blockchain, which is a type of distributed system. And I'm not a cryptographer. Originally, I'm not a cryptography expert. I'm not an AI expert. What I quickly discovered after joining iExec almost 6 years ago is that T's had a lot to bring to decentralized computing. And of course, AI is now the new and most exciting use case for decentralized confidential computing. You cannot not support AI. You cannot not do AI. But also, AI really brings fascinating challenges. I would say that are very different from the ones that you would get previously. So I wasn't forced into it, but it came naturally and a little bit recently for AI. I would say.
So that's great. It sounds like you're in the right place at the right time. Is there anything that you love about your daily work in particular?
Oh, recently, so I have three PhD students, a few engineers, and so there's my time is about 50% theoretical foundation research and 50% proof of concept prototypes. Recently, because of AI and because of really new stuff in T's like TDX, new ARM specifications, I've been doing more proof of concepts, more prototypes. I've seen more of my results come into production, and that's really super exciting. That's really what researchers want, right? They don't want to just write papers. They want their research results to go into production and being used by people. And this is kind of new to me because I joined again 6 years ago, exact. So it took a lot of time to find the problems, set the team in motion, do the research, write paper, publish, implement, test. And so now I'm really reaching the goal line of some of the projects I started like 4 or 5 years ago.
Wow. Yeah, it sounds like it's much nicer to have real world applications, isn't it? We're
Yeah.
going to dive into some of the other questions now that we have.
Yeah, and it's phenomenal that you've been so methodical and taking your time in developing this. It feels like we've got some of the most brilliant minds working in this space now. It can be more exciting, and that now all your hard work is coming to fruition. So congrats on that, truly. And now that we do have you here on the show, we're going to ask you just some questions about the inner workings of what's happening at iExec and how you're tackling these different issues, which we find really interesting. So the first thing is, the time-old problem of how can we ensure that AI models process that sensitive data without compromising the privacy, right? That's one of the most important points here.
So yeah, what we want to exec is confidentiality, privacy, but also ownership, governance. So the way I define governance is basically, like I said, your users, they should be able to set rules on what happens to the data, and the rules they include kind of pricing and monetization. Uh, so there is governance, and for implementing that, we need a mix of cryptography, encryption, end to end. So I should be able to encrypt my data myself on my device, because if I delegate the encryption to someone else, then it's already lost. I don't know what the person could have done with it. I need to execution environments so that the data can be used and processed within a secure environment. And it's the same for models, obviously. And we need blockchains and smart contracts to make sure that all of the rules and the payments happen uh, safely. So, how can we ensure AI models process sensitive data in a privacy-preserving manner? DCC, Decentralized Confidential Computing. That's so obvious for me. It's hard to say more.
Right. So that would be the user essentially taking control over their own data. Yeah. Very interesting.
Yeah, so that's kind of the role encryption plays in making AI truly confidential. I think you've addressed that. Um, Specifically, can you talk about the role that TEEs have in that process?
Hmm. So the thing is, encryption is great. But there's only so much you can do with it without TEs. So, for example, if you don't have TEs and you want to process or you want to do AI securely, what you have to do is basically do it on your own device. You have to have a server at home. You have to secure that server. You have to make it very airtight so that everything that happens to it is isolated from the rest of the world. And you need to have a powerful server, and you need to be knowledgeable. And all of this is not accessible to everyone, right? And also, even if you could do that, you can only do it for yourself and for your own data. Like, if I want to make my own chatbot, I can do it at home. It's complicated, but I can. Now, what if I want to let you use my chatbot with your data? Then it's not enough. I cannot prove to you that I'm doing things correctly and safely. So TEs are good for that. They allow you to provision a space somewhere. You don't have to know where. You don't have to know who. You don't have to trust all of these people. And you know that your AI, your application will run securely there because it cannot be modified, digged into, or meddled with.
Right. I think a lot of applications today, both in Web 2 and in Web 3, have you heard this term, trust me, bro?
No, this the one.
The
Of course, sorry. Yeah, of course. So I was at GTC last week, and that I think Trust Me, Bro is it was a big part of the conference. So I saw that at GTC, confidential AI is not yet a big topic, but there's private AI, and the answer to private AI is Trust Me, Bro.
Yeah.
We will do it in our own data center. Don't worry, it will be isolated. You'll have your home network, but
We will never look at it. We will never share it. We promise.
yeah.
Yeah, I think I give this example on one of the podcasts, but Apple, suddenly people were getting pictures that had been deleted years ago popping back up on their phones. And it's like, wow, okay, so what does that mean? Right. And all of these things, like I have a VPN and the VPN says, hey, your data leaked on this, data leaked from this site, from that site. It seems to happen rampantly. Right. So there is a problem here. And this is seemingly a really great model to be able to solve that.
Mhm. I
Yeah.
think it links back to ownership and governance, right? The very basics is you should know what's happening to your data. You should know why it's popping back, and you should know why it didn't happen 5 years ago, and you should know why it happens now, why you didn't really agree to it.
Right.
Well, good luck figuring that out in today's world.
The $1 million question, $1 billion question,
Mm.
maybe. Yeah, that's very interesting. I don't know now if we take the advantage of moving over to the next area about scalability, right?
Mm.
I think that's the next big topic. So, on that note, can the confidential AI scale in high performance environments like finance, like healthcare, or like where we would need to apply the technology first and foremost?
Okay, I don't have my crystal ball, but what I can say is 2 years ago, I would have said, wow, that's hard. Probably not. Now seeing especially the new accelerators, NVIDIA GPU, H100, H200, I can safely assume that yes, we are getting there. Uh, when I started with these, it was only HGX1 and this very limited memory. Then there was HGX2, more memory, TDX, less swapping, more application support, and now we get GPUs, and they work pretty well. They work surprisingly well. We have very small overhead. They're very expensive machines, these GPUs. The downside is you cannot really buy one easily. The upside is they're expensive, so they're in data centers, so they have high speed network. They are surrounded by very good hardware, high performance environments, and so now the answer is probably yes. Yes, you can probably scale AI to do even high performance trading and things like that. Yeah, that's. I
Yeah.
think it should be demonstrated very soon if it's not already been done.
Yeah, you raised a really interesting point, which is the networking speed. And if it's in a data center, I think it's very difficult to scale with GPUs unless you have the communication between the GPUs very, very fast. And that either means you have to co-locate your GPUs or you need a very high speed network between GPUs. I'm not sure that that's widely recognized in the industry yet, that you can't just have GPUs dotted around the world and expect to be able to scale. There's some additional infrastructure needed.
But to be honest, this is a concern for some people, but I'm struggling to find the use case for that. Most people don't even train models. Most people who train model, they just fine tune or they add some training. They get a foundation model, so for example, Olama or I don't know, stable diffusion for image generation, and then they just had a little bit of training. All of this matters, GPU interconnection and so on. It only matters really if you start training from scratch. And another trend I found at GTC about inference is most companies, they don't really work with large models. What they do is they prefer taking a small model like tiny Llama or stuff like that. They have between I don't know 7 and 30 billion parameters. They wait until 380 gigabytes, so it is manageable, right?
Right.
And they train that. Uh,
That's
so
interesting.
apart from Mistral and OpenAI, not many people actually need that many GPUs.
Yeah, that's an interesting point. Large language models are a somewhat limited use case, right? And then we have medium or small language models or agents that maybe they don't require multiple GPUs to be networked together. Very interesting. Okay, so how do we build AI systems? So the next question really, let's say we can scale. Okay, great. We can scale in confidentiality, but how do we make sure that the systems are accurate and verifiable? Um, verifiably confidential for one thing, attestations, but also that we know what data went in and we didn't get any data in that we didn't expect.
So that's actually the one use case where you would want to do all of the training with DCC, and so I'm going to contradict myself. But the idea is, if you can set rules on data and the model is piece of data about how it's read and written, then you should be able to do something like, I have these data sets. These are data that I can trace back to, so to their owner, these wallets or whatever. Uh, I have a process for using them in training a model. And once I have that model that is trained, I have the full trace on the blockchain about which processes, which servers, when, how, with which software, which version of the software, which version of the libraries. and of course which input data sets. So if you do over the training in a T, you get these benefits, and then that gives you it probably gives you verifiability, but not accuracy. In the end, you know how the model was made. You'll still not necessarily know why the model behaves in a certain way, right?
I see. So you're defining accuracy as being able to predict the the answers accurately.
Yes.
And
Right.
is there any kind of benchmarking that's done on AI models to determine how accurate they are?
Yeah, of course. That's really not my area of expertise. So I know they are. I look at them. I forget about them immediately. What I can tell you is this is also a great use case for T's and for decentralized confidential computing. Imagine you have. Actually, you do have, so you don't have to imagine. Look at Hugging Face. It's a repository of models. You can go and look at them. You can try them on. Uh, you have a lot of models that are duplicated, right? You have this Orama 1, Orama 2, and they look the same. Sometimes they only have a few bytes of difference. You can use benchmarks in T's to evaluate the models, determine clearly with a cryptographic proof that this model, for example, is good for your use case. And no one can cheat that. When you sell your model, it might be precious, it might be private. If you sell it or if you rent it to someone, you can prove that person that your model passed the benchmark and got the result that is expected by your customers. And because of this, you can sell it for more, for example.
Oh, that's interesting. Yeah. Um, well, so now within the whole realm of we've covered, is it scalable? Is it accurate, but also verifiable? Then the next question would be, what's the difference between explainable AI and verifiable AI?
Um, Again, more of a T expert now than an AI expert. My understanding is explainable AI is more an application layer. So it's AI software engineering. We want to understand why a model gives you the answer that it's giving you. Uh, Verifiable AI to me is more like the execution layer. It relates to, let's say, did my model run in a safe environment? Were the inputs modified? Were the gradients in my model modified? Was the output modified? Is the output I'm seeing really coming from the model? So one is really application, the other one is execution or infrastructure. And confidential computing, the way I understand it and the way I see it in my project right now, can actually uh, contribute to both. But they sit at a very different level. I might be wrong, though. It's really not my area of expertise.
Yeah, no, it's there's a lot of nuances and a lot of different sectors, and of course, like expertise within those bigger sectors. There's just so much to it here, in the whole AI realm and TEs, and it's yeah, it's a whole nother world. So
Yeah, so let's kind of get back to your area of comfort, which is teas. And this is the Spilling the Tea podcast. So, it makes sense. It's fun to talk about AI because it's a hot topic right now and it's a good use case. But really, coming back to how trusted execution environments improve AI safety and control and governance, what are the trade offs of using TEEs to enforce AI governance?
Um, so I think like in the AI governance, what we also really want is um, safety, controls, guardrails, predictability. So basically, uh, you want your environment to be safe, right? And so there are two tracks to that. There are safety measures that are embedded within the models, and there are safety measures that are embedded in the runtime. So it's about validating the input, verifying the output, make sure that they don't say anything offensive, anything dangerous, and if in a perfect world, if T's were unlimited, what we would do is take entire models, terabyte models, put them in a T. You would take their environments, put them in a T. You would take all their data sources, put them in a T, and then you'd have something completely airtight. You would be sure that the model is not being modified, that if there are safeguards embedding in the models, they are not removed. You would make sure that the input from the users, like the prompts in LM, for example, really go through the filters. They don't like go around. And it's the same with the output. You would make sure that they don't circumvent the safety checks. But you probably cannot do that. So the more control you want, the more it will cost you. And this is also an issue because TEs are not only limited in performance, they're also expensive. And when it comes to GPUs, it looks like we are more going towards a shortage than anything else. It really looks like demand is a little bit higher than offer right now. So as in any application, you still have to think of a trade-off between what you put in and outside of the TE. Like I said, it's very interesting for us. It looks like most industries outside of the biggest, like 3 or 4 players, are going towards smaller models. They prefer to have smaller models because the accuracy or quality trade-off is not that favorable. If you take a large model and you compare its tiny version, usually, I don't remember the figures, but basically, if you go from 30 gigabytes to 300 megabytes, you will lose maybe like 50%, 15% accuracy. But you get such a speed up and you reduce the cost by so much. Most people just do that.
Yeah, it's very interesting. It's great to have somebody on with your knowledge and expertise to kind of walk us through what you've been through. All of these perspectives, they help, as this whole industry has been driven forward.
Then we've tried and we've hit walls, and it's all starting to make sense now. So 1 year ago, when people came to iExec and said, "Can we do this, do that?" I was like, "Oh, I don't know. I ain't try." We've tried a bunch of stuff. Now we pretty much know what works and what doesn't. I'm sure it's the same for everyone. So now we can get to like do the work.
Yeah. Well, before we speak about like future targets and challenges, what have been some of your biggest challenges working up to this point?
I think it's to be honest, it's still probably there are two. There's key management. There's always this issue of key management because we talked about cryptography before, but the weakest link is the private keys, and the other one is UX. All of this is fantastic, but in Web3 UX is always a problem, and the problem aggravates when data. Thinking of the model again, data becomes larger. So a few years ago, 3 gigabytes was a lot of data for iExec. Just too much. So we had to work on that. Now we can handle it, but running an IPFS node, making sure that your application can get the data from the IPFS node in less than 15 minutes. That the application will not time out because of download time. We will not spend more time encrypting the results than we spent doing the computation. All of this is just very challenging. And when people AI is like the rest, right? I do decentralized cloud computing, so people hear cloud computing. What they expect is applications that are immediately available, interactive, and so they don't want to wait several minutes until something happens. And it's the same with AI. People are used to LLMs. They type an answer, they type a question, they get an answer. If you tell them this is so much more secure, but please wait 5 minutes until you get the answer to your
Yeah.
questions, then it gets difficult. So yeah, latency, for example, is a big challenge.
Okay, that's very interesting. The first two I didn't expect as much, although there are logical problems and just across the board, not specific to TEs or AI, the keys and the UX. I mean, that's a problem with crypto in general and why, our adoption rate is, still as it is and not higher. But the latency, yeah, I can understand that because even when I'm in ChatGPT and I'm plugging something in or whatever I'm using, if it takes longer than half a second, I'm like, man, what's going on here? Like, why is it so slow? Right? So, but then the trade-off is, okay, with the TEs and all the rest of the security measures, you know what's happening with your data, you understand. So, but the average user, it's hard because will they understand that? Will they care about that in the beginning? No. So, yeah, so that's a challenge for the industry, right?
So we have to do the work. We have to think of optimizations. The model has to be close to the processing. The model probably has to be already in memory. We need a way to share model but distinguish the confidential part of the model so that a certain memory space can be shared without exposing data. Uh, all of these is very complicated. It's a lot of yeah, foundation work, and it has to be done so that eventually users will interact with confidential AI the same way they interact with AI, and they will, not just turn away because I think it's too slow.
Right. How far out do you think we are from reaching that point?
Mm.
It's hard to estimate, I know, but it's interesting to get an idea,
Okay, yes,
of where.
wrapping the days, I'm thinking of my KPIs, and um, I think we've done the complicated work, and now we're already in the optimization space. So I think a couple of years should do. I've already seen really impressive demos. I'm expecting to see more working on our own. Yeah, 2 years to be. This is this is the bias that I have. I always try to be super careful. So saying 2 years,
Yeah.
but I'm sure that this year we'll see very exciting things.
Wow, it's happening so fast, It's here now. It's very exciting. And also, now that we're on that note, what do you foresee being your biggest future challenges, like midterm, next 2 year challenges as you get to that point?
It's hard to say. It always depends on the use cases. I'm sure someone will come with the most challenging use case, and we just have to to play along. Um, right now, harder than interactivity. I can't really think of. I cannot really imagine serious applications in the blockchain. I mean, with this Web3 space around robotics, for example. That would be super interesting. Can we make rules about whether a car can go or not go? Can we understand why it turned right or not? Can we monetize the way it drives, for example? But that's to me, that's moonshot, for example.
Right. There's a lot of unknown out there that will be discovered as you go. So it's hard to predict the error of them.
Here to play experts, but actually, we just I was just trying to surf the wave and understand where this is all going, and more importantly, we're trying to understand what people want because we always have this toxic behavior of trying to push technology that people don't want, and at the same time, people struggle to do simple things. So it's
Right.
all about listening to the market and what people want.
Yeah, hard thing to do. Well, Anthony, thank you so much. It's been very educational talking to you. You definitely have a deep knowledge in this space, but I love your sense of humor too and your honesty about what you forget immediately after reading. Next refreshing. Thank you for joining us today and sharing your insights on TEs and AI. It's been a pleasure having you.
Thank you, Anthony.
It's been a pleasure. Thank you so much.